floor.
Thank you. Hello and welcome to the second in a series of webinars from Car Design News. My name is Johannes and I'm the group editor here at CDN and Interior Motors. Before I introduce today's presenter, just to remind you that today's webinar will last for around 45 minutes, made up of a 30-minute presentation, followed by a Q&A session for another sort of 10 to 15 minutes. Please post questions at any time and we'll try to respond to as many of you as possible. Today's webinar is entitled Visualization, Illumination and Sensing, Designing Next Generation Automotive Interiors with LEDs. Joining us today is Michael Godwin, Director for Visible LEDs at Osram Opto Semiconductors in Detroit, Michigan. So if I could hand over to you now, Mike, thanks.
Thank you, Joanne. My name is Michael Godwin. I've been with Osram for about 10 years, and what I wanted to do today is kind of walk through some of the new emerging trends with LEDs in the interior and invite you to ask questions on the chat line, and Chris and Brent will be there to ask questions as we go, or we can table that for later on in the discussion. So with Osram Opto being a leader in the automotive industry, we've made several accomplishments if you look back in terms of history in interior ambient lighting in the car. Dating back to 1990, some of the first vehicles, BMW launched an orange branding theme with orange LEDs in a top-lid package, which is then migrated into what we know as a Volkswagen Blue, which was Blue Makes Happy as a branding initiative. In the early 2000s, Osram participated in Lincoln programs with Lincoln White as well as Cadillac White, with a satin nickel finish with Lincoln winning prestigious awards. Most recently, we've won some additional prestige with our Color and Demand awards, with PACE Awards, which is a fully saturated LED as opposed to a pure LED as in the initial instances of LEDs in the early onset. The other award we've recently won has been being selected as the LED source for such iconic vehicles as the Ford My Color with a Mustang, which we'll touch on. If we look at LED visualization, illumination, and sensing for the consumers, LEDs give the designers a new palette of digital control to deliver the convenience and also more emotional ambience for really the next generation of vehicles. How we can accomplish that, there's a lot of trade-offs with that. And in this presentation, really intend to go through several items. One, to discuss the LED value proposition and how it creates emotion, overview of LED technology, what is really driving the trend, why it's important for the next generation interiors, light and perception as it relates to how we see and sense, light and materials, and then a more specific topic on color and how color is important, probably one of the most critical attributes with light. Then bring in some of the emerging optical sensing technologies and try to pull it all together to really kind of drive the next generation interiors. So if we look at architectural lighting and what it can do, it actually is a key way to inspire us into what we want our next generation cars to look like. These are all the same images with different colors. So on the far right, you see a blue image with blue LEDs illuminating in some architectural artwork. Also with pink, with a color mix of pink and green, you get a totally different effect. On the left side of the image, you see other ways to illuminate textures. So you can actually draw out textures and depth and control that you can't see in other types of lighting technologies. So very impressive. So this is one way that we can look at the interior design and try and inspire us as to what our next interiors need to be like. Why LEDs are important, if you look at LEDs, LEDs can save really power. They're a green technology, and one figure of merit, in the onset of LEDs through the course of many years, the power savings has been associated with the execution of LEDs. Today, in the ambient lighting and the dome light, one dome light represents about 8 watts of possible savings that you can convert that power into other usable functions in the interior. So the power savings is definitely critical when you look at what you're trying to accomplish and how you're trying to attract tomorrow's consumers to your vehicles. The other advantages with LEDs, and it's been demonstrated through the exterior, interior, is really warranty savings, the ability to mount it as an electronic device. You save in warranty. Lighting historically has been very high in the warranty Pareto from the car makers. With going to semiconductor technology with electronics, you reduce those failure modes. The other thing with LEDs is LEDs are directional. The light is emanating in one direction as opposed to in all directions that needs to be collected in the form of a reflector or some other type of optical treatment, so that the directional light can actually enhance and actually reduce the energy as well as get the light where you want specifically. Then also delivering the comfort, convenience, and also the environmental friendly point that I mentioned. So these are all driving factors as to why they're important. If we look at LEDs in optical sensing, they're to be seen, to see with, to deliver a message, as in this display, or to really deliver emotion or style or flaunt your style, to create an effect that you can't do with other lighting technologies. So these are some of the things that LEDs can bring, in particular with some of the optical sensing technologies for the next generation interiors. LED technology, if we look at this Ford Mustang GT, you see a lot of different illumination. You see the instrument cluster, which is executed with an RGB multicolor LED, also with the backlighting buttons, which is shown with our color on demand, which is a fully saturated Ford Ice Blue color, as well as the display. So all of these are showing different levels of lighting technology in the form of things to be seen or to create different style. So what's behind the LED technology and how an LED works is very basic. The LED is basically a crystal material that, with current applied, you're able to create photons of light. Those photons are then extracted into the package. In the cases of unsaturated colors and color on demand, as well as white LEDs, we use blue light as the light source. So that blue light is then emitted through the package. There's a reflector wall and a lens, and also some electrical contacts that actually manage the thermal, the optical, as well as the electrical. So this is the basic construction of an LED for tomorrow's vehicles. Osram Opto Semiconductors has been making LEDs for close to 30 years now, with really heritage back with Siemens Semiconductors. Today, with the breadth of portfolio that we have LED products that really fit almost any application, which we'll touch on. How an LED works, and these are some technical terms related to how we measure an LED and how you really look at the color of an LED. Luminous flux is a metric that we define in terms of the amount of light, the quantity of light generated from the LED, and then luminous intensity is the intensity at a point spot, of which may have different requirements. So every application in the interior may need to specify one or both of these elements. In the area of an RGB LED, the RGB LED has three different chips. There is a blue chip, a green chip, and a red chip. That has a narrow bandwidth that gives you that type of a spectrum as shown in the chart above. In the full conversion LEDs with a blue chip as well as our color and demand, you have a blue device which is actually converting phosphor, which Osram manufactures phosphors as a lighting company, and we're able to create a much broader spectrum, or an unsaturated color as is shown here. So two different indications of different LEDs, of which really same form factor in the end result from electronics and packaging, but achieving two different qualities of light. When we look at the automotive LED applications, we start at the front of the vehicle, and we'll go to the back. Forward lighting has probably got the most interest in the public because of its power savings and also the benefit of style and the other effects. We know this in terms of some of the things that have been demonstrated with daylight running lights, which have been mandated in many countries in Europe, to really using the LED technology as a signature theme, as Audi has in their eyebrow classic of the daylight running lights. The other key thing with LED headlamps, and also with exterior headlamps, U of M Umtree has determined that there's upwards of 400 watts of power savings that can be accomplished with this. That's a tremendous savings when you look at the energy issues with trying to make more fuel-efficient vehicles. The more classical and more very interesting from a styling side on the exterior is that LEDs are actually jewelry that you can actually put on the end of the vehicle. Osram Sylvania, our sister company, has actually launched various system products that have been able to use this jewelry to create signature themes on the exterior of the vehicle. So the LEDs not only save power, but they also create some additional style in the vehicle. What we're going to talk about today is really emerging interior trends in the map, dome, reading, ambient lighting, as well as LCD backlight. These are some of the key emerging areas which really have been untapped. Today, there's still a lot of incandescent lighting technology that's used today, and by converting to LEDs, you can take advantage of the power as well as some of the other digital control and some of the other styling effects that you can't achieve with other lighting technology. When we think of ambient lighting, You can think of this picture of in your home and your room with ambient lighting that is actually projecting on the texture of the brick wall. So you can have a very cool scene, which is showing this skiing as seen in the image there on the left, or a very much warmer, comforting color, which is reflected off the wall with a warmer scene. Really, this is the power of ambient lighting, how you can actually live in your environment and actually enjoy what you're doing or driving. So taking that type of idea, as we all have TVs at home, and relating it to the interior, there's a lot of things that you can do to actually create this emotion. I'm going to walk through some of the ways that you can accomplish this, but first start from the traditional mindset when we look at interior lighting. Traditionally, we've put incandescent light sources in the overhead and illuminated into the map or into the laps of the driver and the passenger, as shown here. So putting lighting in the overhead is a common practice. It's something that we always do. The directional light source, there could be some distractive light or stray light in the edges, but in essence, that's what the light is doing. What you can do with LEDs is you can actually illuminate other areas. So you can illuminate the seating, cup holders, floors is another example, doors, in the instrumentation, as well as in the center stack, and also in vents and other speakers and other types of attributes. So because of the limited power that's needed for an LED, you can package LEDs in almost anywhere you can imagine in the interior. So illuminating things that haven't been illuminated before are very possible with the size and the directionality of LED lighting. Looking at the hierarchy of lighting control and how that's used in the interior, you can think of your map light as on the left of your steering wheel, where you have an on-off and a dimmable switch. So that's probably the most fundamental basic feature that a car has. As you move forward or up into the hierarchy of this, you can add other features such as welcome and farewell with additional dimmability, additional control, where your car is actually acknowledging that you've arrived. Color and illumination is even a higher area, which we'll touch on, is how that can be integrated and actually controlling the color to various set points, or being able to create my color as Ford has done with their branding. And the last thing is really integrating some of the advanced human-machine interface controls to basically anticipate what you want to do, sense, as well as to control the light and the function that's needed. An example of this is shown here, where we take this vehicle and we darken the lights, and we have basically illumination. So there's a child in the rear of the vehicle that's reading a book. It might be a Game Boy or a game station, but in essence, the child is in need of light. So in order to avoid the distracting light from the driver, the mother reaches back, just by a wipe of her hand with an optical sensing technology, is able to basically direct the light to that zone that the child needs to read the illumination. All this is possible with LEDs and with sensing technology, so that the driver is undistracted, you get the illumination where it's needed, and you're able to really take advantage of what the technology can deliver. What's driving the trend? If we look at what's driving the trend, there's several factors, and we're going to talk through some of these things as it relates to the car maker, and then also the consumer, and then really kind of bring it back to some of the differentiating things and themes that you can actually create in the vehicle. So the car makers have seen the advantage. The exterior creates the style, the image, the cut line, draws you into the showroom. The interior really closes a sale. You live in your car about an hour a day or 45 minutes a day in an average commute, but with that, the interior closes a sale. Brand differentiation and loyalty. We've seen that in the area of backlighting and branding as the car makers have looked at their colors and how do they create that. Ambient lighting has the same type of effect that can actually differentiate and create some things, unique features that you can't achieve with other types of products. Customer satisfaction and personalization is critical, and also the quality and durability is reduced with the warranty. So these are all benefits that the automaker sees and is able to relate to. The consumer relates in a different way, and there was a research study that was done by Steve Polakowski from Interior that with the focus group, 93% of the respondents indicated that they'd be interested in buying a lighting solutions to improve their interior appearance of their car. What was very intriguing to the statistic is that 50% of them said they'd be willing to pay as much as $200 for that ambient lighting solution. pretty important when you think of the cost of executing and really what kind of value you can package into the interior when you look at your seating and you look at the other controls. Lighting is a definite value option that can be added into the interior of the car. The other thing, individualization and the enhanced sense of comfort and convenience are other things that bring the consumers into lighting. So these are all attributes that really drive the need for LED lighting. The other thing that I wanted to note, and this is in North America and broadly, is in 2010 there'll be 4 million new graduates graduating from college that will be buying a car. So what kind of car will they buy? Well, they're going to buy cars that really they can relate to. They're going to be eco-friendly. They're going to be green. It's going to be very techno-savvy. This demographic embraces modern technology. They're going to demand best-in-class. They want quality products, which is really going to change the demands in the vehicle. So the traditional bulb that's over the overhead illuminating is in the baby boomer or the GI generation is going to be different. The lighting is going to be coming from different locations that you couldn't see before or imagine. So these are all things that are really driving this trend to LED. The other thing that I wanted to highlight is the idea of mass customization in terms of what's important. With this demographic, this Generation Y, they're the first native online population. Their technology is embedded into everything they do. They all own PCs or cell phones in 6th grade for that effect, and that's something that in my neighborhood, that is a common practice, that kids have their own cell phones. They're told through the media that they can have it all. Image-driven, very efficient multitaskers, and the trend is to individualize their world. These are all driving trends as to what the interiors of tomorrow's vehicles need to be when you really look at some of the mass customization demands that are being placed by this demographic. Ford took upon this challenge, and it was a very, very lofty challenge to actually look at integrating not only in the instrumentation but also integrating LEDs into various components within the vehicle. Everywhere from the floors, the doors, to the seats, they were able to package LEDs into a limited space, take advantage of the optic, the power consumption, and able to achieve the effect that they needed to in this Mustang My Color. The key thing with that is that this technology, or lighting technology with RGB LEDs, this is the only technology that is really capable of achieving this. Other technologies, lighting technologies, could not really accomplish this task and deliver the digital control that was desired by Ford. Now as you move into light and perception, I wanted to relate to what we as humans see as light, and then also from the sensing side. So with light and perception, the nature of light, we see our eyes as humans. We have rods and cones in the back of our retina, and we see anywhere from 380 nanometers to 780 or 760. With this, anywhere from near UV to red. The other thing that we have from a technology is Osram has really pioneered several technologies with our thin film, is we manufacture chips and light sources that emit in the infrared area, which is important for sensing. The sensor in this case is not your eye. It's a CMOS camera. It's a CCD camera. It's some type of a feedback that needs to do something. So these are how you can achieve some of the unanticipated effects that you want in tomorrow's interiors. One thing with color in human vision, in order to see the color, as we look at this sun modulating, you have a full spectrum of the red all the way through the violet color. The light is going to be emitted from the light source, as shown in this natural light. In the case of an unnatural light, such as an LED, the color is basically controlled by the chip and the phosphor, as we denoted earlier. The light is going to be absorbed, reflected, transmitted to what you see. What is simulated, what is rendered, is not necessarily what you get. The spectrum of the color, really, you need to have that content in order to see the textures and the features in the interior of your vehicles. The other thing looking at the perception of light is how you can position light differently and change the environment. This is an object that was presented from Rob Miller and Philip Gordon in design, showing the same object with 4 different ways of illuminating it, from the ceiling, the perimeter, the walls, and the floors. Now this could be from your overhead console, it could be from your doors in your car, it could be from your seats, it could be from sconces that are put into the trim on your A and B and C pillar. So these are all different options of trying to drive really what you can see differently with light. So light has a tremendous impact on the object you're trying to illuminate, as well as really the task you're trying to accomplish. Same idea, different sculpture, but the light is basically shown at different angles. And with this piece of artwork, you can see that with 6 different views, you get 6 different images, all being illuminated, all the same artwork, but you get different images. So you can actually create a different effect just by light. Very critical when you really think of what you're trying to accomplish in tomorrow's interiors. If we think of merging creativity then with technology, Osram, as a leader in LED technologies, we manufacture thousands of LEDs and really have a breadth of capabilities to link the technical element. On the creative side, there are several things that may be tougher for us to relate to, as related to transparency that may be needed in the interior, creating a diffusion, outline, color, relief, projection. Probably the most important of those is color. So what we're going to try to do is kind of link how the technical element and the design elements can be realized with really taking advantage of LEDs, to really end with really what your end goal is in trying to accomplish your interior. So with that, as we talk about light and materials, the first and most important part is to really describe the LED advantage. The LED, as we talked about earlier, is a point source. The color diagram here shows all the unsaturated colors in our color and demand palette, which shows the capability of creating that. This is an unsaturated color. A purest color would be something that is a pure red, a pure blue, which we know and have seen in some of the early advent of LEDs. LEDs are instant on and off. They can be precisely controlled, as shown with the Ford MyColor. And then you can also take advantage of the LEDs and moving into the IR to use that as a sensing technology. But there are really 5 basic lighting elements that we want to talk through when we discuss the materials. These elements are the idea of absorption. The light is going to be absorbed. The light is transmitted, reflected, refracted, or the classic case of total internal reflection. I don't want to bore you with the details of all these formulas and equations, but the key things here is that there's basic physics as to what light will do and what light can do. All of these factor into how you select your next materials and how you interact the light with your materials and your design elements. So these are very key to keep note that you have to have those in mind when you're trying to decide on your next design. With absorption, the light and the interaction of surface, the light is classically absorbed, as shown here. A fully absorbed surface may be a matte black, which may turn hot with the amount of energy from the sun, for example. So this is one classic area of absorption. Reflection, or creating relief and shadow. This is showing a piece of leather with light reflected at many angles. The degree of reflection, you can think of the classical looking in the mirror as you're brushing your teeth, that you have the total reflection coming off the mirror with the angle identical to the incident angle. Or a semi-specular or diffuse are other ways that you can create that. So how the material interacts with the light and reflects has a direct impact on how you see that. Transmission, or transparency and diffusion. The interaction of light and surfaces, the light will actually shine through transparent materials and redirect to either a semi-diffuse or opaque. This is an interior of a Chrysler minivan showing really the diffuse nature of the light, as well as how the light is transmitted through the optics projecting into the laps or in the rear passengers. So the light is again emitted, absorbed, and then reflected with some level of transparency. Refraction, which is probably the most complicated of these elements, is the light is going to be bent, is one way of thinking of it. If we think of the classic idea of looking in a pond of water with sun shining and you're looking at a rock or a stone, the rock or stone may not be where you perceive it. So what's happening there is the index of refraction of light and air to that in water is different. The light is bending, so you perceive the light to be someplace that it's not, or the object to be someplace that it's not. These are all classical cases of refraction and how it can be used in the area of projection. An example here, which is really compliments of 3M and Visteon collaboration with X-Wave, they're showing several elements of transparency, outline, and movement, where the LEDs are actually, through total internal reflection, optically coupled through these fibers, as well as in the display and in the pocket control. So these are some areas that you can actually show how blackout films can actually create this. So the blackout film, in this case, is acting to avoid the light from from projecting out. But also when you turn it on or sense it, it's able to show really what you're trying to see. In the area of diffusion, a couple other examples. Interiors of a Volvo here, you can see a very diffuse light. Again, an unsaturated color, much more warmer than a pure color. You're able to see really the diffuse nature of this and several components that are shown in the design. The other area of diffusion is in the headliner, where you have a starry-eyed, starry sky look in the headliner, which is accomplished with a fiber and an LED light source, albeit a much larger light source, to pipe the light to the various nodes that is integrated into the headliner here, all of which are possible in showing some of the ways that light can be managed in the interior. This is a screen showing the possibility of sensing. So if you can imagine approaching your hand to the button and the knob and basically seeing the illumination of the backlight, this is another indication of how sensing can actually interplay with lighting to really get the effect and draw the attention to what you want to see or not see. So again, transparent materials using sensing as an example to accomplish that. In the area of refraction or projection, the classic projection light is basically illuminating from a headliner into your lab, but you can get more sophisticated with that, as shown here with a projector, a literal projector that's projecting the color and the texture into the fabric from Citroën, courtesy of Philip Gordon, both of which are projection devices. The light is more controlled in the area of a projector with the color and the texture, whereas the white light is more random and you're able to get the functional light that's needed, of which you can manage those two very differently. Two different issues, but accomplishing projection. The classic case of total internal reflection really drives at some of the things that as car makers we like to relate to, and that is really outline. How do you want to create the look, the feel of the vehicle as shown in the image on the right. And the applications that you see that are in the areas of cup holders, so the light is guided through a light guide, or in doors on a contour where you're showing the illumination coming from the pocket door, and even in the exterior, as we highlighted earlier in some of the signature themes that have been demonstrated in the forward lighting DRL. Probably the most critical and the most important thing to relate to is color. This is an image of interior with various colors from Citroën, showing the idea of projection of color into the various seats, as well as some textures and some patterns, as well as some of the illumination coming from the floor into the footwell, where you can see the various colors. Very intriguing when you think of the amount of complexity it can bring, but this is important when you think of in a welcome and farewell. So this is your car, you're approaching your car, what do you want it to look like? And this is something that you're really driving a message by having this in your interior. When we think of color, some things to think of is white is not necessarily white. The definition of what a white LED as we know it is related to the sun. The sun rises and then it sets, of which it's measured in the terms of color temperature, which is shown here. So a warm white at 3,000 Kelvin is shown here with the object in the backlight with the colors. As I pan through the other colors, we have neutral white, which is 5,000 degrees Kelvin. And then finally, we have the cool white, which is a much cooler white, which you might see at nighttime, of which are all driving a different effect. So what you're trying to accomplish in the interior with color and how it renders on the materials, the textures in the skin has a direct impact as to what you're trying to accomplish. So with that, to kind of summarize that point, is that the color temperature is not a perfect measure of lighting quality. It is a measure of lighting quality, but it's not the only one. The color rendering is also another measure of lighting, but it's not perfect as it relates to LEDs. So the spectrum of the material that you're emanating from the LED source, as well as how it interacts with the textures, has a direct interaction to drive the effect. As shown in this images courtesy of Optis, where you're looking at the cabin of an aircraft with a warm white, cool white, and then also the much more sterile cooler white in the bottom, of which all have a different spectrum of white, as shown in the images on the right. If you bring that all together and you kind of think of how you can relate the unsaturated nature of white and colors and also the purest colors of blue, this is showing a Boeing Dreamliner with really the execution of all this light in the interior. So you can create a very dramatic theme to really accomplish your end goal with looking at these textures and the interaction of these surfaces and light. Now I'm going to move into sensing and sensing technologies as it relates to this. If we think of in the infrared area, as we noted earlier, this is light that you do not see. So this is 760 nanometers and higher. The classic example is an emitter and detector. So as you approach with your hand or with an object, the light is going to reflect off your finger into a detector, and that detector is going to send a signal to something to say you're there or you're not there. The features that you can add are things such as proximity, multi-touch, or even gesture recognition by integrating some of the optical sensing technologies. One example that Osram is introduced is in the area of ambient light sensing, where we're actually using a device to actually emulate the human eye that behaves very much like it. So in a very daytime image, you're able to reduce the amount of light, and in a very dark, you're able to increase the amount of light, depending on how you want to perceive the display or the image that you're trying to achieve. This is using ambient light sensing to really drive at the point of readability that the human can relate to. Near proximity or motion, the idea of taking your finger or your hand and actually detecting the direction and which way you're going. These are things that have been done in the silicon area to the point where these analog-specific devices are available. Elmos has promoted this with the usage of infrared light and the idea of actually detecting the proximity or motion with the motion of your hand. How that technology works is very similar to an LED. You have an emitter. This emission angle is, or this emission is of infrared. The light is going to be reflected off of your hand and then collected into the detector to basically then send the signal. So the technology is very basic as it relates to that. Another example of that is in the area of digital dash. Digital dash has taken this to a further extreme. We're taking a projector, projected in the rear of the vehicle, and a camera, in this case a CMOS, or it could be a CCD camera, and using that as a means of detecting the proximity of your hands. So implementing multi-touch, where you can touch with 2 fingers and spread or widen or change the view, are all possible when you really look at the integration. Some images of what they've been able to showcase is in the area of, in the center stack, you could create an HVAC control mode, a rear camera view mode, or a radio mode, all based on a projection that's tied into the center console. Probably one of the more innovative and things when we think of the gaming industry, which this demographic, this Generation Y, all relates to with all of our technology at home, is really the idea of gesture recognition. So taking the light coming from the surface and actually anticipating where your hands are moving, how you're operating, to really drive at the HMI interface that the car can have. So these are some of the things in the future that you can think about how to integrate into your next generation interiors. So putting it all together, if we really think of back to the vehicle, putting illumination is very simple from an execution of LEDs. So you can personalize the light. So you can personalize the digital light by using an LED, an optic, and some electrical to basically create the light where you want it. The important thing from a design and styling is that light has got to interact with the materials and textures. You want that to interact properly. You want surface to be reflected or to absorb. You want to make sure you select those in accordance with really the light source that you're using. And putting that in terms of the area of sensing and control, this is a much higher level from the hierarchy that we talked about, so you can actually add additional sensing control to really deliver the end goal, which is your function of design. So all of these can really kind of be blended together to really create the end effect that you're trying to achieve in your interior. So in summary, and then we'll open it up for questions, so if we think of it from a design side, the LED adoption, as well as from the lighting and the sensing, they're going to continue. It's going to continue. It's a good technology. The consumer can relate to it. There's a definite trend to increase the adoption of LEDs. Effective illumination in sensing really can deliver the emotion and ambiance, as we talked about, in the area of the ambiance in an LCD TV to what your next generation interiors would be in your car. Surfaces that have never been illuminated can be illuminated today. It's just a matter of packaging. You're using different materials, different tools, all of which are using 5 basic fundamentals of light, but you're able to accomplish these things. The car maker has many driving factors: branding, buyer demographics, the energy savings potential, and the mass customization demands. All of these really driving some of these things. dynamically controlled RGB ambiance really is only achievable with LED. So controlling this from an electrical, an optical, and being able to execute that in the interior is really only achievable with LED technology. And the last point is that Osram Opto Semiconductors continues to lead the way in auto interiors really for next generation vehicles using our illumination, visualization, and sensing technologies. So with that, I'm going to open up the floor. We have Brent and Chris available for Q&A, but I wanted to thank you for your time and just open up the floor for questions. Why don't I start with one question to start the dialogue. One question is binning. The question is, why do LEDs need to be binned? And with the human eye is a very, very sensitive organ and sensor, and it's very critical to sense the intensity and color of LEDs. And with that, with the manufacture of the chips, we're able to produce very accurately the color and the intensity that's needed. But in order to get the specific that's needed in the end application, the LEDs need to be tested to test the intensity and or color to really accomplish the end goal that's needed in the application. Okay, I'm looking at a question from Wallace Wagner. His question is it possible to convert an ordinary windshield in a very thin LED monitor to display all the functions of the vehicle without the loose transparency? Very, very key question that he's bringing up. The area of ambient light and how it interacts with the windscreen and the monitor has a direct effect. And there are very powerful software tools to in essence, help with those requirements. So it's probably a question that I can't answer specifically on an LED side, but from an optical science side, the software tools that are available in the market today can allow you to simulate and actually look at those things from a real-life example. Next one from Jack Brown. Jack Brown is asking, can LEDs be linked to temperature sensors in order to change their color, mood, depending on exterior temperature? The answer to that is yes. And what's important with that is that you have to have really either you have to time the day or what the color temperature is, or you have to measure the color temperature in the ambient mood. So it's possible, it's definitely a highly integrated system where you have a sensor of the daylight and have got to actually have some processing to create that within the LED. Then the LEDs in the end application have got to have the ability to tune into the region or the regime that's needed. So Jack's question is that he asked is the answer is yes, but it's a pretty sophisticated execution of electronics control with the usage of LEDs. So that's definitely possible. So we have a couple more questions. Okay, I have a question from Carlos Arturo, and his question is there a software that can closely simulate the lighting effects in 3D interior? If you noted at one of the slides, there are softwares out there. We use a multitude of optical softwares to look at the rays of light from a practical tool. So there's several general practice tools that are used, Light Tools, ZMAC, and there's also software that does a very good job at rendering. That software is called Optis, which does a very good job in what they call visual ergonomics to basically relate the visual three-dimensional rendering to what is actually created from the light source. So the answer is yes, there are software tools to do that. I have time for a couple more questions. Okay, a question from Darren Robbins is, what color temperature would you recommend for map lighting? Can you support this with data? Very good question. I think it's very much a personal question, although I can tell you some experience that I've had with LEDs in the interior when I was traveling. I was actually driving in a city, traveling and trying to read a map and using a classic map, and I struggled with the lighting because the lighting did not have the red content to look at the red lines on this map. So the color temperature is important, plus the color rendering is really critical to that. Depending on the effect and the materials, it's going to really have a direct effect as to what you want to achieve. Creating sunlight is achievable with a warmer white LED, but you've got to look at not only the color temperature, but you have to look at really the spectrum of that light source in terms of what you're trying to illuminate, whether it be a red surface or whether it be some other colors. So color temperature is definitely important. A specific color for map lighting, I think from a functional task, a higher color rendering, I would recommend something that's in a map function in the 5500 Kelvin range, really in the cool white that I was identifying earlier. But that's a typical area, but you'd have to look at that and actually make your own decisions as to whether that's suitable for the application. There's a question from Mark Willows. Do you think mood lighting will be linked to audio infotainment? I think the answer is yes. It's already been executed and demonstrated with some of the vehicles that we've seen. So having speakers that actually illuminate with the pulsing of the sound is very doable. It's been done in the aftermarket. How that's integrated in the interiors with color, those are some other things that can be explored depending on what you're trying to do. So definitely a very good question, and one that there certainly will be a trend to move that way.
Thank you, Mike. I think we're going to have to wrap up there. So my thanks to Mike Godwin at Osram Opto Semiconductors today for his insightful talk, providing a real eye-opener, I think, into developments in the area of LED illumination and sensing. Please feel free to provide your comments and feedback via the Car Design News forum. You can also post further questions there if we just haven't had time today. And also, if you'd like to view this webinar again in the future, a link will be posted on the CDN website, hopefully in the next 24 to 48 hours. And you'll also find details there of all our forthcoming webinars. So thank you very much for joining us today, and we look forward to seeing you again soon.
That does conclude the conference call for today. We thank you for your participation. You may now disconnect. Have a wonderful day.